Hello and welcome to Algebra 2. Today is Friday, October 9th, and our topic for today is multiplying and dividing rationals, where a rational, again, is just a function that is a fraction. Okay, we are only going to do two examples today. That is because they are pretty involved. So, our goal is going to be as organized as possible. So lots of pausing, maybe some color coding, numbering and lettering, nice and neat and organized, because it is very easy to get lost on these problems. Okay, so you should pause here and write this example down first. Pause wherever you need. You don't need to wait for me to say pause or anything. Okay, we're going to dive right in. The first thing we want to do is factor everything. Let's write that down. We're going to factor everything. So I'm going to use a color coding system to keep track of what's what. If you don't have colors with you, you can also label everything A, B, C, and D. I'll use color coding and labels. Pick whichever works for you, but you need some kind of system to keep track of everything. Okay, so let's do my yellow part A. I have 3x squared plus 7x plus 2. All right, let's factor this. I get 6, make my x, 6 here, 7 here. Let's do 6 and 1. I'm going to need to build a square because of the 3 up front. So I've got 3x squared, 3x, x, 6x we take out a 2. I am going a little quick. Factoring is review at this point. Pause and rewind as much as you need. Plus 1x, plus 1. My 2's match up, so I'm all set. So this in factored form is 3x plus 1, x plus 2. And this is our yellow part A. Okay, let's do our blue part B. I've got x squared minus 2x minus 8. We can go straight to our x because our a value is just 1. I have negative 8 and negative 2. Let's do negative 4 and positive 2. Because the a value, this is our a value, in front of x squared is 1, we don't need to make a square, so I just get x minus 4 and x plus 2. And we're going to write this. This is our blue B. Okay, let's go do our C. We'll make him green. So I've got my A, I've got my B. We're going to put C over here, nice and neat and organized. Organization is definitely an individual preference, but you need some kind of system that you stick to. Okay, I'm going to make my X for this one. Double check that we wrote the right thing. We did. I've got negative 4 and negative 3. Let's do negative 4 and positive 1. So when I factor this guy, my C is x minus 4 and x plus 1. And this was our green C. Okay, just one more at this point. Let's try orange. That's okay. All right. So I've got my orange letter D is x squared plus 3x plus 2. Let's double check we have that right. We do. So I've got a positive 2, a 3. We're going to do a 2 and a 1. So my orange D is x plus 2 and x plus 1. Great. Now we just plug everything back in where it came from. So I'm going to start that right here. I've got 3x plus 1, x plus 2 up top, and then I have x minus 4 and x plus 2. My green up top here was x minus 4 and x plus 1, and down here I have x plus 2 and x plus 1. Great. Now all we do is cancel. You can cancel any numerator to any denominator. For example, these x minus 4s will cancel. Even though they're in different fractions, any numerator will cancel to any denominator. Let's cancel these x plus 2s and these x plus 1s. And all we're left with are these two guys. They stay in the same position. So I have 3x plus 1 and x plus 2. Nothing left to cancel. That's my final answer. Pause and rewind wherever you need. We're going to do our second and final example. Okay, let's call this example 2. Make sure you pause and write the original problem. So, I see a division sign instead of multiplication. We are going to do a keep change flip for multiplication. So, let's rewrite this guy. I've got the first fraction is our keep. We won't change multiplication to, change division to multiplication, and flip our other fraction. Okay, now it's a multiplication problem, and we treat it the same way as our previous example. So when we see division, just one little extra step at the beginning, we do a keep change flip. All right, let's do my part A. This looks like a greatest common factor. The only thing they have in common is y, so I'm left with 5y plus 1. And that's my yellow part A. Great. Let's do part B, blue. Y squared minus 1, that's a difference of squares. 1 is a perfect square, because the square root of 1 is 1. And we get y plus 1, y minus 1. And this is our blue part B. Okay, let's do a part C up here. We'll make this one green. This is factoring where a does not equal 1. We know this because our a value is 4. So I've got 4y squared plus y minus 5. I'm going to start off by multiplying my 4 and negative 5, negative 20. And I get, this is an assumed 1, so positive 1 down here. Let's do positive 5 and negative 4. I do need to make a square because my a value is not 1. It is 4 in this case. So in here, I've got 4y squared. We're going to take out 4y and y. Minus 4y, I can take out a minus 1, plus 5y, 5 minus 5. Great, that checks out. So my factors here are 4y plus 5 and y minus 1. And this is our green part C. Okay, great, just one more. We're going to make this guy our orange part D. Okay, that's 10y squared plus 2y. Always double check these. 10y squared plus 2y, great. Greatest common factor, what's in common? How about 2y? What remains? 5y plus 1. And this was our orange part D. Alright, great. We're ready to plug back in now. Okay, the 5y squared up top. We're going to do this right here, nice and zoomed out so we can see everything at once. This is now y times 5y plus 1 over y plus 1, y minus 1 times, green was on top, we had 4y plus 5, y minus 1, and then over 2y times 5y plus 1. Great, now we're ready to cancel. These will cancel even though they're in different fractions because it's numerator to denominator. Same thing here. And actually, these single y's out front, we can cancel as well. And we're left with 4y plus 5. We can keep the parentheses, doesn't matter. And the bottom, we have 2 times y plus 1. Nothing left to cancel. This is our final answer. That's everything for today, guys. Thanks.